So guys, welcome to our channel once again. In today's video, we have these 10 questions to solve on acids, bases, and salts. So guys, here we are going to focus on pH and POH scale. So if you feel you want to answer any question before we provide the answer, you can always pause this video and try out the question even before we provide the answer. So guys, let's start with the first question here. That's question number 1. It says, which of the following equimolar solutions will have the highest pH? A, we have sodium ethanoate. B, we have hydrogen chloride acid or hydrochloric acid. C, we have ammonium hydroxide. And then D, we have sodium hydroxide. So guys, here sodium hydroxide will have the highest pH because it's the strongest base here. So we know that basicity increases along the pH, whereas when you get down the pH, that's how acidity increases. So sodium hydroxide, being a strong base, will be the one with the highest pH here. HCl is an acid, so it will have a pH that is very low. Also, sodium ethanoate is an acid as well. So guys, the correct answer to this question is option D here. So let's quickly go ahead and check out the next question. That's question number 2. So guys, the question says, which of the following indicates that the aqueous solution is basic? A, when it contains more hydroxyl ions than hydroxonium ions. B, when it contains more hydroxonium ions than hydroxyl ions. C, its pH value is low. D, it has a sour taste. So guys, the answer to this question is option A. When a substance contains more hydroxyl ion than hydroxonium ions, we tend to describe such a substance as basic. So the correct answer to this question, guys, like I said, is option A. So let's quickly check out the next question, and that's question number 3. It says, what's the pH of a 2.50 times 10 to the power of negative 5 molar solution of hydroxide? So guys, for this, we are going to quickly zoom into our workspace and try to solve this together. So first of all, we know that the ionization constant of water is concentration of hydrogen ion times the concentration of hydroxyl ion is equal to 10 to the power of negative 14. So guys, having established this, we've been given the concentration of the hydroxyl ion, and that's 2.50. So guys, if we want to try this out, let's work with this and this. We know that if we make hydrogen ion the subject of this formula, so guys, we don't have a scientific calculator here, so we are going to make use of a standard way to solve this, and we're going to place this as 1 times 10 to the power of negative 14 over 2.5 times 10 to the power of -5. So guys, 1 over 2.5 will give us 1 over 2.5. That's 0.4. Alright, so we simply have 0.4 here. But guys, times 10 to the power of what? So we're going to simply make use of the law of indices to calculate here. So let's wipe this. So we'll have -14 plus 5 and that's a -9. So guys, this will be a -9. So 0.4 times a -9 is the same as 4 times 10 to the power of -10. So guys, we've gotten the hydrogen ion concentration. So we're going to wipe this off, and then we're going to use the hydrogen ion concentration to get the pH. Remember, we are asked to get the pH. So pH is the negative logarithm of hydrogen ion concentration. So already we have our hydrogen ion concentration to be 4 times 10 to the power of -10. So guys, if we take a negative logarithm of this, so usually if we had a scientific calculator, we would have just pressed this here. But then if you don't have a scientific calculator, guys, this is one easy trick you can use. So this is one trick I like using, especially when I have multiple choice questions. So if I want to calculate the negative logarithm of this, and I'll just simply check the power and then make the power a positive 1 and subtract 1 from it. So this is, the power is -10, so I change it to positive, and that's 10, and then subtract 1 from it, and that's 9. So I'll have 9 points. So I already know that the pH here will be 9 point something. So I can simply go to the option and check the one that has 9 point something. But guys, for this particular value of 4, if it is 4 times anything, then the next number here is going to be 4. So you can always take note of this and use it whenever you're solving your JAM. So the pH here will be 9.4, and that's the answer to this question, guys. So let's go ahead and wipe this, and let's move on to the next question. So guys, the next question is question number 4, and it says the solution with the lowest pH value is A, 20 ml of M/8 HCl, B, 50 ml of M/5 HCl, C, 5 ml of M/10 HCl, and D, 10 ml of M/10 HCl. So guys, the answer to this question will be option B, and this is owing to the fact that the concentration here will determine the pH. So guys, the one with a higher concentration here is option B here, and that's M/5HCl, and that's the acid with the highest concentration, and that's the one that will have the lowest pH. So guys, let's quickly check out the next question, and that's question number 5, guys. So guys, question number 5 says the color of methyl orange in alkaline medium is A, pink, B, yellow, C, red, D, orange. So guys, the answer to this question is option B, and that's yellow. So let's consider the next question, question number 6. It says the pH of a solution of 0.25 mole per dm cube of hydrochloric acid is A, 13.40, B, 12.40, C, 14.40, D, 14.60. So guys, we're going to zoom in right here and solve. So basically, from this question, we have first of all, we have to write out our equation. Guys, you need to have this equation at the back of your mind because it's very important. This will give 1 times 10 to the power of negative 14, or simply 10 to the power of negative 14. So guys, when we have this, we need to input the necessary values. So the equation says we have a hydrochloric acid. So guys, the concentration of this hydrochloric acid is the hydrogen concentration because it's an acid medium. So we are going to input that here, and that's 0.25, or simply 0.25 times 10 to the power of 0, because we want to actually put it in form of indices so that we can really balance well, and since we're making use of a standard calculator, and then we'll add this, and this will give us 1 times 10 to the power of negative 14. So here guys, we are going to bring up our calculator in order to solve this. So guys, making OH concentration the subject of this equation, we're going to have 1 times 10 to the power of negative 14 over 0.25 times 10 to the power of 0. So guys, if we do 1 over 0.25, we're going to have 4. So let's go ahead and write it here, 4. So times 10 to the power of what? So guys, having 10 to the power of negative 14 minus 10 divided by 10 to the power of 0, and that's 14 minus 0 is simply 14. So negative 14 minus 0 is simply negative 14. So guys, we'll have here 10 to the power of negative 14. So guys, the hydroxyl concentration have been obtained. So since we've obtained the hydroxyl concentration, we can now get the POH. So guys, remember that the POH is the negative logarithm of the hydroxyl ion concentration. So guys, since we've gotten this, we are going to simply do negative logarithm of 4 times 10 to the power of negative 14. So guys, remember what I told you about getting the logarithm of a number this way without having to use your calculator. 10 to the power of negative 14 here. So you're going to change this negative 14 above here to a positive 14. So you have 14, then subtract 1 from it, you have 13, then points. So guys, since this is a 4, you're just going to repeat 4 here. and that's 13.4. So guys, the POH of this question is 13.4, and that's the answer to this question. So let's go ahead and wipe this, guys. Let's consider the next question, and that's question number 7, guys. So question number 7 says, what is gamma in the equation gamma equals negative logarithm of hydrogen ion concentration? So guys, the answer to this question already is pH. We don't need to stress so much on this. So option A here will be the answer to this question. Remember that pH of a solution is the negative logarithm to the base 10 of the hydrogen ion concentration. So guys, let's quickly go ahead and check out the next question, and that's question number 8. It says, what is the pH range of solutions containing acidic ions? A, 7 to 14, B, pH of 1 to 6, C, pH of 8 to 14, D, pH of 0 to 7. So guys, the answer to this question is option D, that's pH of 0 to 7. So solutions containing acidic ions have a pH value less than 7, and that's what indicates their acidic nature. So let's go ahead and check out the next question. That's question number 9, guys. The question says, a blue litmus paper turns red when dipped into a solution. What does this indicate about the solution? A, the solution is acidic. B, the solution is neutral. C, the litmus paper is faulty. D, the solution is basic. So guys, the answer to this question is option A. The solution is acidic. Remember that acid turns blue litmus paper red, whereas base turns red litmus paper blue. So guys, that's important for you to know as well. When it comes to acid, base, and salts, you should know which one turns the other litmus paper to whatever it turns it to. So guys, remember, acid turns blue litmus paper to red, whereas base turns red litmus paper to blue. So let's look at the next and the last question, and that's question number 10. It says, 3 drops of 1.0 mole per dm cube solution of sodium hydroxide are added to 20 cm cube of a solution of pH 8.4. The pH of the resulting solution will be A, unaltered, B, greater than 8.4, C, less than 8.4, D, close to that of pure water. So guys, the answer to this question is option B, and that's greater than 8.4. So this is because of the fact that the solution added is a strong base, and that's sodium hydroxide. So guys, it will increase the pH. Remember that basicity increases across the pH scale. So guys, as you add more of this strong base, there is an increase in the pH of the solution. So guys, that's it for that question. The answer to this question is option B, and that's the fact that the solution will have a pH that is greater than 8.4. So guys, that will be all for this video. Thank you for watching this video. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, feel free to drop your question on the comment section below, and we'll ensure to give you a response. Also, we want to encourage you to join our channel membership. So guys, see you in the next video. Thank you for watching this video.